Good morning, students. This is SIVAKUMAR, working as assistant professor in the Department of EEE VSB Engineering College, KARUR. Today, I am going to discuss about the topic of transmission line parameters. It is the Unit 1 first topic in the transmission distribution subject. Before going to see about the transmission line parameters, first of all, you should know about the structure of electrical power system. Normally, the power system we can consist of three sections. It is a generation, transmission and distribution. So the power system we can say it is a combination of generation, transmission and distributions. The power is generated in the generating station. So this power will be transmitted through the transmission line and it will be delivered to the generating station. From the generating station it goes to the various consumers. So this is the way of conveying the power from generating station to the distribution stations. Okay, so this is the structure shown about the electrical power systems. So here we have three topics about the generating station, and another one is the transmission section, and third one is the distribution section. Okay, so in generating stations we generate the electrical power as well as the voltage in the value of 11 kV. At maximum 33 kV voltage is generated in the generating stations. After that, the generating station will step up the voltage with the help of the step up transformer. This 11 kV is increased to 132 kV. So that is given to the primary transmissions. Okay. So normally we are transmitting the voltage at high level because the customers will receive the same amount of power what is generated in the generating stations. To receive the constant power at the distribution stations, we have to increase the voltage, then we can transmit the power from generating station to the distribution stations. That's why we are step up the voltage and given to the transmissions. So here the transmission, we have two type of transmission. One is the primary transmission and another one is the secondary transmission. Okay. So 132 kV is given to the primary transmission, then it goes to the receiving stations where the 132 kV is reduced to 33 kV. So the primary transmission, the main function of the primary transmission, it transmits the 132 kV voltage from the generating station and it reduces the voltage and goes to the receiving stations. From the receiving stations, again we are step down the voltage from 33 kV to 11 kV, then that will be transmitted to the distribution stations. So this setup we can see the secondary transmission. In secondary transmission, again we are reducing the voltage, then it will be given to the distribution stations. So in the distribution stations, we are reducing the voltage from 11 kV to 33 kV, 11 kV to 400 volt or 11 kV to 230 volt single phase supplies. Okay, so the bulk customers, the bulk consumers, they can get the power directly from the primary distributions. Okay, so 11 kV can be directly given to the bulk consumer and medium consumer. Then after that it goes to the secondary distributions. From the secondary distributions, the 11 kV is reduced to 400 volt or reduced to 230 volt, which may be given to the three-phase supply consumers or single-phase consumers. Okay, so this is the structure of electrical power system. Next thing we'll see about the classification of transmission line. So the transmission line, it is classified into two sections. One is based on the supply goes to the transmission line. It may be classified as DC transmission and AC transmission. And based on the construction of the transmission line, it is classified as underground cable and overhead cable. Okay, so you know the DC means it is a direct currents. Okay, the magnitude of the quantity does not vary with time, that is called direct current. AC nothing but it is a alternating current. The magnitude of the quantity is varying with the time, that is called alternating current. Normally in our India we are using majority of the transmission line, we use only the AC transmissions. Okay, but we have some advantages and disadvantages in both AC and DC transmission line. So let us see one by one. So first we will see about the concept of the DC transmission. Okay, so in DC transmissions we have a lot of advantages. because the DC transmission, it contains only two conductors. So because of the two conductors, the losses in the transmission is very less. Okay, so if you compare the AC transmission, it may be a three-phase transmission, means then we have 3-wire or 4-wire. So compared to the AC transmission, the DC transmission contains only two conductors. So the two conductors will carry more power, so the losses are very less. Okay. And one more advantage is that is there is no inductance effect, capacitance effect, and phase displacement, as well as the surge problems. Okay. So while using the DC transmissions, okay, the inductance effects are 0, as well as the capacitance effects are 0. Only we have a resistance effect, and I already told the losses are very less because only resistance are present in the DC transmission. So that is, it is mentioned, it is a less voltage drop because the resistance only present in the DC transmission line. So we have only I into R drop, IR drop, that is called less voltage drop. Okay. And it is a voltage regulation is improved compared to the AC transmission because the losses are very less, voltage drops also very less. Okay. And one more advantage is that there is no skin effect. Okay. So if you are allowing the AC current in the transmission line, so AC currents only concentrate outer surface of the conductors. So there is no current is flowing in the inner part of the conductors, that is called skin effect. So the skin effect is not present in the DC transmission because there is no inductance in the DC transmissions. Okay. And losses are very less because only I squared R losses are available, only two conductors, so losses are low. Okay. And only two conductors are available, so ultimately the insulation requirements are very less, and there is no frequency in the DC, so automatically there is no issue of stability problem. Okay. So even though we have a lot of advantages, again there is a drawback in the DC transmissions. So first one, the electrical power. The electrical power will not be generated at high voltage. So that is the main drawback. DC voltage cannot be generated in the range of 33 kV, in the range of 132 kV DC. That is very difficult. So that is one of the drawback of the DC transmission. And step up and step down the DC voltage, it is not possible. So that is one more drawback. So we cannot transmit the high voltage DC. Okay, so because there is no option of step up and step down the increase or decrease the DC voltage, and we have only the limitation of high rating of switches and circuit breakers while using the DC transmissions. Okay, DC circuit breaker, high rating of DC circuit breaker and high values of switches is not manufactured. So that is one of the drawback of the DC transmissions.